Here is what we are going to build today. You see the charts here, top trending games showing all the game titles which are currently dominating the player activity. Momentum shifts showing which games are staying, leaving and entering the top 100 games. Price versus sentiment showing how pricing correlates with the review positivity. Developers performance showing how studios are winning, losing attentions in the market. Player counts over time on how popularity evolves across hours, days and weeks. And everything you see here is not downloaded from Kaggle or CSV. This is the live Steam market telemetry, fetched every hour, transformed, cleaned, and then visualized. And today, we are going to build this entire engine from scratch. So here's the plan. We are going to create a real-world data pipeline using Steam Web and Store API and also Steam Spy API, which will be orchestrated through Airflow, where all of these charts you see right now will actually be powered by the ingestion pipelines we built in this video. So this is going to be an end-to-end project from raw data to staging, cleaning, aggregating, and then analytics stage. So you will see how we fetch top 100 performing games every hour, live player counts, reviews sentiment signals, games catalog metadata, and then we are going to run transformations to standardize these data across bronze, which will be our raw data stage, silver, the cleaned and aggregated data. Till this stage, the core data engineering part will be done, and then we are going to wear the analyst hat and then turn those silver stage tables into dashboards like this. And this will be our gold stage, the analytics insight. And yes, did I forgot to mention that we are not going to write all of the code manually. We are going to leverage Cline, an open source AI coding agent, and use it extensively to generate boilerplates, REST clients, tags, SQL models, and transformations for us. And I will be providing you the Cline prompts too, so that you will see a real engineering workflow where the humans focus on the architecture and the correctness, whereas AI agent writes almost 80% of the coding groundwork. What you will learn in this by the end of this video, you will know how to use Cline AI coding agent. So this part will be a bit longer because we will be vibe coding live, debugging and fixing things together in real time. How to write Airflow DAGs for real recurring pipelines, basics of hourly incremental ingestions in Airflow, how to clean and standardize the data, how to use Streamlit to build visual dashboards, calling external APIs like Steam and SteamPy using Python, working with bronze, silver, and gold data staging concepts, database, in this case MySQL integration, and writing SQL queries. So if you ever wanted a portfolio project that is not just a weather API again, this is your chance. Let's start from zero and build these dashboards, the ones you're seeing step by step. Let's talk about starting with the overall architecture. First, we are going to fetch top 100 games and store it in the table called trending games with the app IDs. Then we are going to run 3 steps in parallel. First one will be to fetch the game details and store it in the game catalogs table, fetch player counts, store it in player count table, and then finally fetching the game stats, storing it in the popularity stats. Once all of this is done, we are going to then clean and aggregate the data and store it in the game's clean table. Talking about the stages here, you can see in the yellow will be our raw data, which is called brown stage, and the silver one will be our clean data. And then finally, the gold one will be where we are going to do our data insights. That's where we are going to build the dashboards using Streamlit. And this is going to be an hourly data pipeline. That means that every execution will gonna have a run date and run hour. More on that will be on the next slide. So let's move on. Steam does not let you request past timestamps like any other APIs do, for example, weather APIs. Instead, Steam only returns right now live matrices. So in our Airflow task runs at, let's say, 2025-11-4 at 2 a.m., we fetch the top 100 games at that exact moment, and we store those app IDs into the database with run date and run hour. And that's it, simple snapshotting. So every hour, one snapshot. Later, we are going to compare all of these snapshots to measure the trends. Right, these are the 3 core APIs that we are going to use to fetch data from Steam. The first 2 are owned by the Steam themselves, Steam Web API and Steam Store API, whereas the third one, Steam Spy, is a third-party API. Interestingly, about the Steam Web API, their docs does mention that you need an API key, but for a lot of public methods, it actually works without it. At least for the endpoints that I have tried, like fetching concurrent player counts per app ID, that call still returns valid data without API key. I don't know, possibly because these endpoints return public data only. maybe nothing sensitive. Still though, I would recommend keeping an API key configured in your environment just in case, Steam locks down certain calls in the future, or, its rate limits change later. So you can request the API key by filling up this form by signing into your Steam account. Right, so let's talk about the exact APIs that we are going to use in this project. First one, where we need to fetch the top trending games, we are going to use this Steam Spy endpoint. And here is what it returns: a JSON response with app IDs as a key and app details mentioned underneath. For this task, we are just going to fetch the app IDs from this response and store it in a list. And these app IDs are the most played games in last 2 weeks. So this is going to be a rolling 14 days window. So that means every hour we ingest, we may possibly see some games are coming into this top 100 or some games are going out of this top 100. And this is going to become our seed list for the downstream tasks. And we'll store it in the trending games table. Next up, we have fetch game details. We are going to use this Steam Storefront API by providing it the app ID. And this app ID, we are going to get it from the previous step where we store the top trending games. And this is what the response looks like for this API call. You can see the details of this exact app ID game. So from here, we are going to extract and normalize key fields which are required, including title, developer, release date, genre, price, description, and platform. Finally, storing this in the game's catalog table. And since this is going to be a static data because the game details won't change quite often, so we are only going to ingest the new games which are not already present in this table, just to minimize the API calls, Right, on the third step, we are going to fetch the live player counts for each of the game, for which we are going to use this Steam API call, get number of concurrent players, by providing it the app ID. This returns the current players, and here is how the response looks like. As you can see, we can get the player counts for this specific app ID, and finally storing it in the player counts table. The fourth one will be to fetch the historic popularity stats for each game. We are going to use this Steam Spy API endpoint by providing it the app ID. And again, for the same app ID, if you could look at the response here, you will get more detailed view of this game. So from here, we are going to extract and store owners, current concurrent users, positive and negative reviews, average and median forever, average and median 2 weeks, price, and tags. And finally storing it in the popularity stats table for each logical date and hour. The fifth step will be where we are going to clean and aggregate the data. So this will include 2 steps. First is to clean and standardize the version of raw data. In this step, we take the raw API snapshots and produce a cleaned, strongly typed silver table for the core KPIs ready for analytics. As this step is going to heavily rely on examining the raw data closely and then correct common issues discovered across the sources. So after I did that, this is what I've found to be cleaned. We'll convert the app ID, concurrent players, and other numeric strings to integer, parse the owners range, and extract the lower bound as estimated owners in integer, converting the price from cents to decimal. We'll drop such rows which are missing the required fields like app ID and name. And we are also going to fill or default optional fields like score ranks to null or discount to 0. Right, on to the second step. Now that the core fields are cleaned, typed, we roll them up into the time-aware KPI rows per game. This is where we'll gather time-aware data points to track core performance matrices for each game. We will distribute these KPIs into 2 categories. One is the time-based KPIs, which is going to change over time, including concurrent players, CCU, average and median play time for 2 weeks. And finally, the other category will be the semi-static KPI, which changes slowly but needs to be tracked for long-term trends. For example, estimated owners, positive and negative reviews, average and median play time forever. We are intentionally not going to rejoin any static catalog fields here, those which are not going to change over time, for example, the data in game catalogs table. So this step basically distills the noisy raw feeds into the compact hourly KPI facts table, which becomes the foundation for all trending charts later. This cleaning phase is deliberately conservative, so we do not override the bronze or the raw tables. Instead, we are going to write in the new table called games cleaned. So every transform is auditable and repeatable. So after this step, the data set is consistent, typed, aggregated, and ready for the gold layer for analytics and insights. So first thing first, you need to make sure that you have the database ready. So in my case, I'm just using the localhost MySQL database. But in your case, if you have configured in cloud or anywhere else, you just need to make sure that you create the database. In my case, I've already created one. Right, so that looks good. Next up, we are going to go to Cline. You just need to install the Cline on your IDE. In my case, I'm using JetBrains. So either you can install it from here. If you're using VS Code, you can install it from here. But in my case, so this is the repository that I've set it up. Currently, it's empty right now. So in PyCharm, you go to the settings and you go to plugins, and here you search for Cline, and you should see over here, and you can just install it by clicking the install button. In my case, I've already installed it. So once you install it, you need to restart your IDE, and then you will see this port icon at the left panel of your IDE. So you just click that. In this window, you will see at the bottom right, plan and act mode. So when you have initial ideas or thoughts, or just want to brainstorm your ideas with the client, you just talk with it using the plan mode. And once you make sure that the client understands all of your requirements, then you need to switch it to act mode, where the client is going to write the code for you. So before talking to it, you just need to make sure that you have correct LLM models defined. So for that, go to settings. And in my case, I'm using different models for plan and act mode. You just need to tick this box, use different models for plan and act mode. And in my case, for plan mode, I'm using the XAI Grok, which is free. Whereas for the act mode, I'm going to use the Anthropic Cloud LLM model, which comes with Cline API. So these models are low cost, but they do the job. However, you can feel free to use any different APIs. Like for example, you can use OpenAPI, Google Gemini, or any others. But obviously with that, you have to keep in mind that they will be costly, and you have to provide the API keys for these providers as well. So for now, I'm using the Client API provider, which is just going to do the job well. So this is the prompt that I'm going to give to the client, and I'm going to provide this whole document to you in the repository as well. So it starts with, just by saying I want to build data pipeline using Apache Airflow 3, blah, blah. I don't want to go through all of these steps because you know what already we are building. So the main things to highlight here are just to make sure that the host that you provide here to the client are the ones that you have database set it up for. Rest, there are quite a lot of bits that I've asked it to do by providing step-by-step things on what needs to be done. One thing that I will highlight here is that every table needs to have run date and run hour. And these needs to be a unique key set it so that we don't have any duplicate data. I'm providing the table DDLs for each of the tasks as well. For step 2 as well, here I'm specifically saying it that do not call the API for the app IDs that we already have, just to minimize the API calls. And also this database is going to be static, so do not add run date and run hour. Other than that, all of the rest of the tables are going to have run date and run hour. Player live counts, again the DDL is provided here. And for the historic data popularity, again the DDL I'm providing here as well. And for the merge and clean, this is going to be a detailed task that I'm providing client on what needs to be done, as we discussed before. And the DDL is also provided over here as well. Again, a note on to prevent data duplications. Here I'm mentioning just to combine app ID, run date, and run hour to keep it as the unique keys. Lastly, I'm also asking it to provide 2 README files. The first one will be about the project overview, block diagrams, architecture getting started, and the second one will be specifically for the database, including the database table details and everything. So that should be all. I'm gonna copy this whole thing and paste it in the client prompt. Make sure you are in the plan mode because we just wanna make sure that client understands our requirements before writing anything. Right, so you need to make sure that you are giving the permissions to read the current directory here, although it's empty, but yeah, it still needs to read it. And there you go. It is providing the full detailed architecture of what it will do and what it has understand from our prompt. So based on the requirements, here's comprehensive plan to blah, 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 blah. Project architecture and structure. Right, so it creates a DAG file and it creates a database file, Steam API, data processing, and utils. It creates an initdb and Airflow config as well, which is good. Key design decisions, that's fine. We'll use the local executor for this one, no containers, SQLite for Airflow metadatabase, that is fine, which is going to be the default when you run a local instance of Airflow using the Airflow standalone. And the DAG configuration is going to be hourly, catch-up is false, the full data flow that we provided. This looks quite plausible. And now I'm going to hit act mode and let it create the project for us. And you see it's running the commands for us as well because we have ticked this enabled box. But again, for writing the files, it still asks you to save it manually. So we're going to say save. As you can see, it has created the whole database file for us first. We're going to hit save. And similarly, it is going to create all of the files. So the Steam API file that it has created looks plausible. Okay, I'm gonna say save, and now it should go ahead with the next one. You can see the cost that is associated with every API call, which is not that bad. It just took like around 2 cents to create the Steam API call, and then again around 2 cents to create the data processing file. I'm gonna hit save. So imagine if we were to write this whole code manually, how long this would have taken us. And now it has created the main DAG file for us as well. Okay, go ahead and hit save. Now it's running the initdb file, where I think I can see it's creating the database if it's not already there. Nice. And I think it's initializing all of the tables as well. And now it's creating the readme file for us. Very nice. As you can see, it created a really nice fancy architectural diagram and quite a lot of useful things in here, including monitoring, performance considerations, troubleshooting, and whatnot, which is very nice. All right, let's go ahead. And now I think the last thing it's going to create is the readme for the database. Right, I think this should be the last bit. So go ahead and hit save. All right, seems like it has done. Now it's providing the summary in the end. And we are going to run and test this now. And obviously, I'm sure things doesn't work at first try, but let's go ahead and see how it looks. So I'm gonna go through the README here and start following the instructions to set up the project. We already have these three. I'm going to go into the virtual environment and run the requirements. Okay, all of the dependencies seems to be installed now. Let's proceed ahead with the next step. Right, it does looks like this init database should be run at first manually, because as it says in the start that we need to run this to make sure the database and all the required tables are created. I'm going to go ahead and run this init db file. There you go. It created the database for us and it creates all of the required tables. So let us go ahead and verify that in the database. Show databases. Nice, it creates Steam Games database. This is what we are going to use in this project. And show tables. Nice, it has created all of the tables for us as well. All right, let us go ahead and run the Airflow standalone command. Right, so as you can see, it says that it is going to create a beta data database under the home directory here, but I think that's not what I wanted to do actually. I want Airflow to use this current directory as the home directory, so it creates all of these Airflow configs under this directory. So for that, let's go ahead and create a directory here, Airflow home. And I'm going to set the environment variable Airflow home as the current directory underneath this directory over here, Airflow home. All right, now let's go ahead and run the Airflow instance. For this, we are going to use the Airflow standalone command. So this command actually is a one-liner command which spins up all of the components of Airflow, including the scheduler, API server, and DAG processor. You see now this directory has been populated. And this is what Airflow creates. And underneath over here, you will be provided with the password that it generates to log into the UI. So if you go to localhost 8080, Airflow is going to pop up by providing the login page first. So I'm going to say admin and the password that I copied from the configs. Now, initially, you can see quite a lot of example tags over here, which we are going to disable because we don't want to see the example tags. And also, we want to make sure that our DAG is present, which doesn't look like it is. If you search for Steam, you can't see our DAG. So the problem is that I think if you go to Airflow configs, you need to set this directory to the place where your DAG code lives. So in our case, it's under here, DAGs. So you just copy the path reference and paste it over here. And also you need to disable the example tags. Load examples, just set it to false, right? And I'm going to exit this and run it again. So before running it, you need to make sure that you clear the database because the example tags are already loaded and stored in the database. So you say Airflow DB reset, go ahead, yes. And now run Airflow standalone again. It should now pick up our DAG from this directory. I can see no example tags are being populated now, which is good, but I also see another error here, which if you click on this and you will see our DAG has an error. Unexpected keyword argument schedule interval. I think this is what Cline made a mistake, because in Airflow 3 this keyword argument is not used anymore. So this is what we are going to fix now manually. Again, if you are new to Airflow, obviously you won't know anything about this error, because I've been using Airflow 3 for a while now, so I know what this error is about. And again, you see Cline is not always perfect. So especially the LLM model that I'm using, maybe it's not smart enough to identify this, but you can ask Cline to fix this for us, or you can fix it manually as well. So go to your DAG code and search for this. I think this is just called schedule. Shutting down and starting it again. So this is again another error which Airflow 3 is not compatible with, because Airflow 3 does not uses provide context anymore. Again, you may struggle with these errors initially, but feel free to ask Cline to fix this for you by simply copy pasting this. In fact, let me do that this time now instead of manually fixing it. I am seeing error contact. Okay. I'm just gonna switch back to the plan mode and see what it thinks about it. Okay, it's asking us to switch to the act mode, because it's possibly wants to replace the file, but it does provide the reasoning. It says that Airflow 3 has removed the provide context parameter. That's what I was talking about exactly. But yeah, it wasn't smart enough to identify this while it was writing the code. So at least it has found it out now. So let's switch to act mode and let it fix it for us. Right, cool. Okay, looks good. Go ahead and save. I'm going to restart Airflow and run it again. Hopefully this time it should be able to parse the DAG. Refresh. Very nice. You can see our DAG is up and running. At least the Airflow is able to parse our DAG. Okay, the moment of truth. Let us go ahead and run this. So first you make sure you enable it from here. And I think it's just gonna run it by itself now. Yep. There you go. And it has failed the first task. All right, let's go ahead and see what the error is. Right, so you see the error here. Python type date cannot be converted to source database. Okay, I have no clue about this error. It's something that how the client has written the code. So I'm just gonna provide this error to client to figure this out for us. I'm just gonna copy this and provide it back to client. Right, let it think about it and see what it comes up with the reasoning on why it's possibly happening. Oh, right, okay, it has already started fixing stuff for us. Okay, I even don't know what the issue was. Right, so if you click this, what it's thinking, you will see possibly what it found out the problem is that the run date and Python date direct object returned by the get run date logical, but in MySQL needs a string formatted. Okay, that's fine, cool. No worries at all. Thank you so much for fixing it. I'm gonna go ahead and save it. Let's restart the DAG. Okay, I'm going to restart this task. Clear task instance. Confirm. Let's see. All right, seems like it succeeded now. Successfully inserted 100 trending games. Okay, interesting. It's running the fetch game details and fetch player counts, but it failed on fetch popularity stats. All right, let's see why. Found 100 app IDs to fetch popularity stats. That's fine. It's giving me this attribute error. String object has no attribute get. Let's go back to Cline and ask it to fix this for us. This is happening on fetch popularity stats. All right. Because this code is not written by us, so I mean, it would take me time to, debug and identify the issue. But since it's written by Cline, so it's a lot easier and faster for it to fix it for us. So yeah, let me expand the reasoning and see what it found out. The issue is on this line. Okay, it found out the line as well. Okay, cool. The problem is that the tags, the data tag get tags might even return a list of strings instead of list of dictionaries. Cool, that's fine. Seems like it did something to fix it. All right, go ahead and save. I'm going to restart Airflow, right? Refresh the page. And now this time I'm just going to restart this fetch popularity stats task. Confirm. And let's see if it passes this time. Oh, nice. Cool. And now it's failing on the merge and clean task. Okay. Out of range value for column estimated owners at row 1. Interesting. Okay, again, copy paste this error to Cline to fix it for us. Merge and clean task is now failing. The error, we provide the error. And it's making a change on the data processing file as well. All right. Okay, cool. Now let us go ahead and restart Airflow and finally refresh the page and restart this task, the last one. I hope it passes this time. And there you go. Very nice. Inserted 100 clean records into the game's clean table. All right, cool. Now all of the tasks have successfully passed. Now the main thing for us to check is go to the database and find out how these records looks like. For that, I'm going to use dbeaver, which is a MySQL client app from where you can access your databases here. Steam games, tables. So let us look at the first table first, trending games. Look at the data. It ran for today on the 0th hour, and it has provided us with 100 app IDs, the top 100 ones, with their names, median to weeks, and graded at. Okay, looks good. And what else? So let's look at the games catalog table. This looks okay. 100 games catalog. And what else? We have popularity stats, app ID, run date, and run hour. And it provides the owners, CCU. That looks okay. Player counts table and see we have app ID, run date, run hour, and the player counts. Games clean table, very nice. You can see the current players for all of these games for this specific run date and run hour. So now that our DAG is in a really decent and runnable state, let's talk about something important here, the vibe coding. So, when we started this project, we gave Cline a detailed prompt describing what we wanted, our entire Stream Analytics pipeline with the Airflow and the details about the API, database logics and everything. And voila, it did generate a full working code base for us in just minutes. But here is what we saw. The code wasn't perfect. When we started running it, we ran into quite a few errors, Airflow 3 compatibilities, API related, and other fixes here and there. So, we had to go back and forth with clients, sharing those error messages, letting it debug and patch the code one step at a time. So, you might be thinking like, this may sounds time consuming. Yes, it did take a few iterations to get everything running smoothly, but even with those fixes, it is still way faster than writing and debugging the whole project from the scratch. So because that's the real power of vibe coding, and you're not typing every line, you are kind of co-developing with the AI so that you focus on the logic and the direction while the agent handles the syntax, structure, and the repetitive tasks. And also, one thing to keep in mind is that you may see different errors if you try the same prompt, depending on which LLM model you are using or how your local setup differs. And that's normal because AI code generation isn't deterministic yet. But the important bit is that I did not want it to skip this process or hide the debugging part, because this is what the real AI assisted development looks like today. It's collaborative, it's iterative, and it's honestly pretty amazing once you get the hang of it. So with that, I just want to highlight one more thing, that we built this entire project with Cline, all those prompts, code generation, and bug fixes. And this all costed me just 0.8 cents. Yes, you heard it right. Just less than $1 to build this full-fledged data pipeline project. Okay, anyways, so before moving forward to building the analytics insights dashboard, which is going to be our gold layer, you just have to make sure that you let your DAG run for at least a couple of days to collect as much data as you can, because remember, we are collecting the hourly and the daily data for the games, which is what I've done already, and I have gathered for I think 7 or 8 days already. So this is going to help you visualize the gaming trends based on the historic data that you have collected. Right, so once you have that, now we are going to move ahead and build the analytics dashboards. So this is going to be in a total separate repository. And again, we are going to use Cline to build these dashboards for us using Streamlit. And don't worry, you will be provided with this exact prompt as well. So with this, I'm not going to go through the whole vibe coding process again, because it's gonna take a while and I don't want to prolong the video. I'm just gonna show you what Cline built it for me using this exact prompt. One thing to highlight in this prompt here is that actually I am providing the two README files that we generated from our ingestion DAG. So these ones, README and README database. So the client can understand what our database looks like, what our table structure is, etc. Right, so this is what client has generated the code for me by using exactly this prompt. You see it has a dashboard.py, and then under charts you can see different Python files for each specific chart. So let us go ahead and run this, and I'm gonna say Streamlit run dashboards. There you have it. Cool. So the first one is the top trending games. Again, you can filter down by dates to see exactly on which date were the top trending games. You can also see the game momentum analysis. This is where we are comparing the median playtime minutes between the two time periods, morning and afternoon. You can see which games were falling, rising, and were stable based on the 200 minutes threshold. Then we are looking at the player count trends for daily and player counts on every hour. Then we have price versus review sentiments. Basically, this chart is actually showing which games are bargain and which games are overpriced based on their prices and the positive feedbacks. Then we have developer performance, showing which developer is staying on the top of the line based on the current active players counts. And an overview of the market insights, showing who is the market leader, and the detailed comparison of each developer, including market concentration analysis as well. And again, for each of the chart dashboard ideas, I literally just provided it like these three lines, and client just creates another Python file under chart directory and creates this whole dashboard for me. So in this way, similarly, I would encourage you to, play around with this and add more charts on whatever ideas you can come up with. So yeah, that is pretty much it, I guess. So just to conclude, we have built a complete end-to-end Steam analytics pipeline using Apache Airflow, Python, and of course our own AI coding buddy, Cline. From ingesting raw game data to cleaning, transforming, and visualizing insights, all powered by AI-driven development. And yes, all of the finalized code will be provided to you as part of this demo. The GitHub link should be with this video already, which should also include all of the client prompts that I've used. And yep, with that, I hope you found this video helpful. So if that's the case, make sure to like, subscribe, and drop a comment if you have any questions. I will try my best to answer them. And with that, yes, thank you for watching. And remember, code smarter, not harder. Thank you.